What we have is a randomization distribution for testing if the population proportion is 0.3 versus that it's less than 0.3. In each case, we want to use this distribution to decide which value is closer to the p-value. We have 1,000 randomizations in this figure. So when you do these in StatKey, we'll get dots. When we have some of these in the notes, they're histograms. And so this is a visualization of 1,000 randomizations of what p-hat values would be likely or that we'd expect to occur if the null is true and that we really have p equal 0.3. So the first question is, why is this centered at a value of 0.3? And that's because what we're simulating is what we'd expect if this is true. And if that value is true, our p-hat values that we're seeing in the picture should center around that true value. So the first answer is just that we look at the distribution of p-hat when the null is true. And null value is 0.3. So these will always be centered at whatever we're testing for in the null. Then it asks the p-value for p-hat of 0.15, what is it closer to, 0.04 or 0.4? So if I look at a value of 0.15 in the picture right here, that would be p-hat equal 0.15. We want to look at the tail area beyond it in the direction of the alternative. Since I'm doing less than, I want to look less than 0.15. And so whatever percentage of the graph that is our p-value. We can't actually count dots or anything to see exactly, but if we sort of look at what percentage is that out of the total, 0.4 would be close to half the graph. We definitely do not have that. So our correct answer here is 0.04. We're looking to the left of this 0.15 value. Then the last part says, which proportion, a 0.2 or a 0.1 as our p-hat, is going to provide strongest evidence to suggest the null is not true. So if we look at the graph, a p-hat of 0.2 happens quite often, is pretty likely when we have a true null value of 0.3, but we can see that a value of 0.1 is not as likely. So the one that provides stronger evidence to suggest the null is not true will be the p-hat equal to 0.10. And that produces a smaller p-value, a smaller tail area than the value of 0.2. So we have a smaller p-value for 0.1. And we also can say something like p-hat equal 0.10 is less likely than a sample value p-hat equal 0.20 if the null is true.